In lesson 2.6, we started looking at some special types of functions. In your assignment, one thing that you're asked to do is, having been given a graph, see if you can identify which of the special functions it is. In 16 and 18, we have three possibilities: a step function, constant, absolute, or piecewise. When you look at 16, we have a graph that for the most part looks like a V. So if I were to slide the graph up a little bit, we would have something where every value is positive or possibly every value is negative. Anytime you have a graph that looks like that V, that is going to be an absolute value graph. In number 18, we know that's not a constant graph because a constant graph is going to be a horizontal line. It's just an equation where you equal some sort of constant. We also know it's not a piecewise graph because piecewise means you have one graph for a chunk of x values and it changes to another graph for the other x values. Absolute value we saw in 16, so number 18 is going to be a step function. Step functions are also known as greatest integer functions because you're not graphing y values that are fractions or decimals. Many of these graphs you'll create on your graphing calculators, which you probably worked on in class. If you don't have a graphing calculator, you still can talk about what kind of function you have and its domain and range, which is what number 30 is getting at. If you try to do number 30 with paper and pencil, the first thing you need to do is come up with a graph so you can talk about its domain and range. For that, you can pick different x values and plug them in. Let's say I try graphing -3, -2, -1, 0, 1, 2, and 3. When you plug them into an absolute value, -3 becomes 2 times -3, which is -6. The absolute value of that, which is the distance from that number to 0, becomes +6. When you plug in -2, you get -4, the absolute value of which is +4. -1 becomes +2. 0 becomes or stays 0. 1 becomes 2. 2 becomes 4, and 3 becomes 6. Now when I graph those, -3, 6, then -2, 4, -1, 2, 0, 0, then 1, 2, 2, 4, and 3, 6. Now, when you're talking about the domain of the function, you're talking about what x values work within the equation. Can you plug in positive x values? Yes, you can multiply 2 times a positive number and take the absolute value of that. Can you take negative numbers and plug them in? You can. -2 times 2 will give you a negative number, which you can then take an absolute value of and again find a point. Fractions and decimals also work. That's why the line is solid. So if positive, negative, and fractions and decimals work, your domain is going to be everything, all real numbers. -infinity to infinity. Range is looking at the other value, the y values. We'll ask the same questions. Do positive y values work? Yes, the graph shows you positive y values. Are there any negative y values on the graph? There's nothing in the third and the fourth quadrant, so there are no negative y values, only positive ones. That means we're going from 0 to +infinity for my range. And now you've talked about the x values and the y values which work. That's your domain and your range.